All right, let's take a look at systems of equations using elimination. The goal of elimination is to get rid of one of the variables, okay? So in this first example, it's set up perfectly for us that if I were to add these two equations together, I would get 9x, my y values would cancel, and that would be equal to 27. And divide both sides by 9, and you would now have x equal to 3. Now you could take either equation, which they both seem to be about the same amount of work, rewrite the equation. I'm going to replace my x value, copy everything else down, and solve. So I've got 9 plus 3y equals 21. I subtract 9. I've got 3y is equal to 12. Divide both sides by 3, and y is equal to 4. So now I've got my two values. I've got an x of 3 and a y of 4. We always want to check and make sure. So I'm going to do 3 times my x value plus 3 times my y value. And that equals 21, which is the first equation. And now I'm going to do 6 times my x value minus 3 times my y value. And that's equal to 6, which is my second equation. So I know that 3, 4 is the solution. The second example looks a little bit different because there's nothing that we can cross out right away. But what I want to do is manipulate or change one of the equations so that there is something to cancel out. There's two ways you can do this. You can choose to cancel out the x's, or you can choose to cancel out the y's. If you want to cancel out the x's, you would have to multiply the second equation by a negative 2. Because then I'd have a positive 2x and a negative 2x. If you want to cancel out the y's, you can just multiply the bottom equation by a 3 because the signs are already in the position where I want them to be. That's the one that I'm going to choose. So my first equation is going to stay the same. And my second equation, you have to make sure you distribute the 3 to every piece of this equation. So that's going to give me a 3x minus a 3y equals 3. Now when I am going to add my equations together, those y values are going to cancel. I'm going to get 5x is equal to 10. Divide both sides by 5, and I now know that x is equal to 2. Okay, let's take one of the equations. 2x plus 3y is equal to 7. And you can pick whichever equation you prefer. You will get the same answer. So I've got 4 plus 3y equals 7. Subtract the 4. 3y is equal to 3, which means that y is equal to 1. I'm going to put my answers together into one coordinate of an x and a y. And now I would like to check my answers. So 2 times my x value plus 3 times my y value is equal to 7. So I know my first equation is good. And my second equation, you can do in your head, 2 minus 1 is 1. So I know that I am correct. So when you're finished, take your answer and plug it back into both equations from the original question to see if you're correct. Next example, I've got 2x minus 5y equals 18 and 7x plus y equals 26. If you wanted to cancel out the x's, you would have to multiply both equations in order to do so. Okay, I'd have to multiply the top equation by a 7 and the bottom equation by a negative 2. To cancel out the y's, all I need to do is multiply my second equation by a 5, so that now in my first I've got a negative 5y, and in my second I have a positive 5y. So those will cancel. So rewriting 2x minus 5y equals 18, and 35x plus 5y equals, let's calculate 26 times 5 is 130. So when I add my equations together, my y values are going to cancel. 37x is equal to 148. Take 148 and divide it by 37, and that is going to equal 4. So when you divide both sides, you get x is equal to 4. Take either equation, we're going to rewrite it. We're going to replace the x with the 4 that we just got. And now we're going to solve for our y variable. So 8 minus 5y is equal to 18. Subtract the 8 to the other side. Negative 5y is equal to 10. Divide both sides by negative 5. Y is equal to 5. Putting your answers together, I have my x value of 4 and my y value of 5. And let's check what we have. So taking your first equation, 2 times our x value minus 5 times our y value equals, okay, so here I know that I made a mistake. Ah, I see the mistake. I did that on purpose. Negative 2 would go here. So we need to make sure that we are checking that we get a correct answer. So let's try again. 2 times 4 minus 5 times negative 2, and that is going to equal 18. So now I know I went back, I found my mistake, I fixed my answer, I rechecked it, and we're good to go. Let's check the second equation. 7 times my x value plus my y value is equal to 26. We're good to go, okay? So that's a great example of how you can go back, find a mistake that you made, and refix your answer and check it. Let's take a look at one last equation. Here, if you notice, I'm going to have to manipulate both equations, okay? It does not matter whether you choose to cancel out the x's or the y's. What I am going to do is I like to keep my numbers as small as possible. So if I wanted to cancel out the x's, I'd have to multiply by 4 and 5, making one of them a negative. To cancel out the y's, I'm just multiplying by a 2 and a negative 3. So I'm going to choose to multiply by those because I'm going to have smaller numbers. Now, how did I get 2 and negative 3? If I want to cancel out my y values, 3 and 2 both can become 6. We need to find a common multiple that both numbers will become so that we can cancel it out. For my x, the smallest number would be 20, right? And so would you be able to do that? Absolutely. But I prefer to use numbers that are smaller. So make sure that when you're distributing to all 3 pieces. It's very easy to make a mistake when you're distributing and forgetting to distribute to the last piece. Now I've got a negative 15x minus 6y equals negative 99. When I add my equations together, the y values cancel. 8 minus 15 is that negative 7x. 50 minus 99 will give me a negative 49. Divide both sides by negative 7. X is equal to a positive 7. Take one of your original equations, rewrite the equation, replace the x with a 7, and now we're going to resolve. 28 plus 3y is equal to 25. Bring the 28 over to the other side. 3y is equal to a negative 3. And when you divide by 3, you get y equals negative 1. Putting our answer together, I've got my x of 7 and my y of negative 1. Let's check and make sure we're good. So 4 times 7 plus 3 times negative 1 equals 25. So my first equation is good. And checking my second equation, I'm going to plug in both numbers. You get 33. So I know I have correct answers. Okay, so make sure that when you're eliminating, you're making it as simple as possible for you, having something to cross out and solve.